Welcome to the webinar. You have entered as an attendee in listen-only mode.
I hope you guys are doing good. Can you please just quickly confirm if you can hear me and see my screen as well? Okay, thank you. Let's wait for a minute, okay, then we're going to start. Okay, so let's start today's session. So, okay. Okay, so let's just check out what we have learned yesterday, like maybe on the Friday. So on Friday, okay, we have completed module number 4, where we have done the topics like, how to secure a new AWS account, then how to secure the practices to secure the account, then how to secure your data at rest and in transit in AWS, and then we have seen some compliances program. That was all about module number 4, and then I have given you one lab as an homework. I believe if you would have completed, that's good. If not, we're going to discuss tomorrow. Still, I am getting the same issue, so I'll ask him to rectify this issue before the class only, so that I can show you. I can show you how to start the lab, and we can discuss this lab tomorrow. Okay. So who can access the lab? They can try, but I'll tell you how to do it. Okay. Tomorrow, but today I will tell you how you can access the lab. I will connect with them in the break. Okay. So please mute yourself, guys. Okay. So let me ask you questions before starting. So okay. So just tell me how you can how you can encrypt your data at rest inside AWS platform. How you can encrypt your data at rest at AWS platform using. You got answer from Raghuvi. What about that? Where is money? Then I'm asking how you can encrypt your data at rest. Very good, Nathan. So the correct answer is using KMS. The data at rest, the data which is residing on the physical hardware, the physical disk, are encrypted using key management system. So with the help of it, you will get the key. With the help of that, you can encrypt and decrypt your data. Now, how you can encrypt your data at rest? Sorry, at like in transit. How you can encrypt the data in transit? Yes, you can. So we can encrypt the data in transit using TLS SSL certificate. And how you can get the certificate at AWS platform? Which particular service provides us these certificates? Which particular service, AWS service, provides these certificates? Very good, Shrikant. What about others? Yes, the correct answer is AWS Certificate Manager. Okay. So which AWS service is used to tackle the DDoS attack? Which AWS service is used to tackle the DDoS attack? It is AWS Shield. Hmm. Okay, anything else is left? Okay, where I can store all the compliance documents inside AWS, all the compliance ISO certificates, all those compliance documents that where I can put. Right, actually I was speaking with Ethnus regarding this error so that they can rectify and I can show you how to access the lab. Yeah. Okay. Am I audible now? So the correct answer is AWS artifacts. The correct answer is AWS artifact. Okay. Okay. So which AWS service, like it is used to like to track the activity of user inside AWS account? Which particular AWS service is used to track the activity of user inside AWS account? Just now, let me just ping them my ID. They can able to access. Yeah, so the correct answer is AWS CloudTrail. CloudTrail is just like a, like it is a tool which is used to track all the user activities inside the AWS account. So the people, so the admin can access these CloudTrail events and they can check the which person has access which like which particular like service and by default for by default like 90 days for 90 days you can save these Cloudtrail logs, but if you want these logs to be saved for a longer period of time, then you have to pay some amount from your pocket and get the Cloudtrail advanced version where you can get more logs generated for and saved for longer period of time inside the S3 bucket. Okay, so I think I think I've covered almost all the questions. Okay, guys, we'll start with today with module number 5. This lab is the one which is pending. So I've already, contacted these guys. They're going to fix this issue now. Then I will show you how to access the lab, and tomorrow we are going to discuss this lab because I still have not showed you how you can access these labs. Okay. So let's start with module number 5, that is networking and content delivery. So this is a like whole module which is about the networking part of AWS. So based on your feedback, guys, I've got few feedback like I am doing a bit fast. I'm using more technical term. If there were 2-3 guys who have given this kind of feedback. So if there were 2-3 guys, Smith, I'm talking about, no problem. I'll go a bit slow. Okay, so let me like go a bit slow and I'll try to relate many things. Like though I'm relating everything with the real time example. So any of you who are still having that kind of a doubt, that kind of a issue, I'm not naming naming anybody out. Please ask me multiple times if you can't understand anything. Okay, because I'm explaining multiple times, 2 times, 3 times I'm explaining the things. But still, if you're not getting, then you can ask me again. Okay, I'll just explain you another time. Okay, thank you. Okay, guys, so let's start now. So inside this module, what we are going to cover these topics. First of all, we are going to understand what are what are what is this what is it networking basics. Then Amazon VPC. What is Amazon VPC? Then about VPC networking, VPC security, and after that, once we will complete the VPC, then we will move to Amazon Route 53 service, which is a DNS service, and then finally Amazon Route CloudFront, which is a content delivery service. There are a few activities here, label a network diagram. So once I will show you how, what are the different components of VPCs, how these are interconnected, then we are going to label a network diagram. And finally, we are going to design a basic VPC architecture. Based on one scenario, we are going to design a basic VPC architecture. Apart from that, there will be one demo, VPC demonstration. This will be a lab. This will be a demo where with the help of small demo, I'm going to show you how you can use VPC, how you can create VPC on the VPC console. And finally, we have one lab here which is mainly, like how to build your VPC from scratch. So you're going to build your own VPC from scratch, and then inside the VPC, you're going to launch a web server. That will be our final task, which will incorporate all the learning here. And then we will have a knowledge check. Knowledge check that only are one or two questions that you have to answer based on this particular module. Okay, so after completing this module, what will be able to learn? How to recognize the basics of networking, describing virtual networking in the cloud with Amazon VPC, how you can use VPC to create virtual networking in the cloud, label a network diagram, how to understand what are the different, by seeing you will understand, which is what is the name of a particular component of a VPC. Okay, design a basic VPC architecture, how to design a VPC based on the client requirement, indicate the steps to build a VPC, how to build a VPC, identify security groups, what are security groups, create your own VPC and add additional component to it to do a customized network, means how to create your VPC in short. Then identify the fundamentals of Route 53. We are going to see what is Route 53, what are different Route 53 policies are there. And finally, Amazon CloudFront, what is this technology, what are the, we are going to discuss some of the details about this particular, Amazon CloudFront AWS service. Okay guys, so let's start with section number 1. So where networking basics. So first of all, what is network? Okay, this is a very basic part. What is network in general? So network is used for communication between two machines or two users. Suppose, for example, if like we both, like I'm calling, like Ashwani, and I'm connected with Ashwani over the call. So how we both can communicate over this mobile? We can communicate through the network. In between, there was some network was set up, and with the help of that, we both can communicate. Suppose I am in Bangalore, Ashwani is in some other part of India, and we both can talk to each other. That is because of the network. Like that, there are machines, there are different machines like, I have my laptop, and my laptop has installed this Zoom application. For it is GoToWebinar, and you all connected from different part of the India, and we all can communicate to each other through a single platform. How it is possible? It is possible through the network only. So network is a way how the machines can communicate or how the humans can communicate with each other. Okay. So this is the basis of network. So, when you create a network, we have multiple components. If you see the diagram, they have defined two components like subnet and router, which we are going to discuss later under the network components. But if you will see the diagram, you can see there are 3 machines on the left side and 3 machines on the right side. And how all these machines are connected? Using the network component, which contains subnets, routers, and whole of these network components build a single network. So we have the subnets, which are the smaller part of the network. I'm just giving you an overview. What is subnet? In detail, we are going to check out in after 10 or 12 slides. Okay. And then what is router? A router is used to define the route. So suppose when I am calling to Ashwani, when I'm calling to Ashwani from mobile, then what is going to happen? There would be some router in between that's going to create a route that my call should go to Ashwani only. If I'm trying to call Ashwani, then the call should not go to Vijana or Durga. It should go to a right path, a right recipient. So it should go. So when I'm a sender, when I'm going to call, I'm going to send some message to Ashwani, for example. It should go to Ashwani only. So with help of this route only, it is possible. This router, because router is going to define a route. So now with the help, there are few other components are also there which creates the whole network. But in general, network is used for communication. It is used to communicate with the help of the networks. Different machines can communicate to each other. Even humans can communicate to each other using the network. That is a basic definition of network. Okay. So let's go ahead now. So now, what are IP addresses? So IP addresses is an address of a particular machine. IP addresses is the full form of IP addresses, Internet Protocol Address. Okay. So suppose in Bangalore, I have a particular address. If somebody wants to send me a letter, if you guys want to send me a letter, then you can send me on my personal or official address. In the same way, each machine has their own IP addresses. Okay. So for example, currently we all are connected with different IP addresses on this Zoom address. So if suppose if you want to if I want to connect with what is it okay, Ashwani, okay, so IP address is Internet Protocol address, Ashwani, and it is an address of a particular machine. Each server is having a IP address. So suppose you want to send some suppose some file to a particular server, then how you can send that file to a particular server? With the help of that IP address only, because that is the address which is associated with your server. So whenever you're going to create a server, a IP will be attached to a server. That will be the address of a particular machine. So today, if I want to, send some file to your computer, Ashwani, then your system is also having one IP. So from my system, I'm going to send some files to your system. Okay, so how the communication, how they will, how the router I was talking about, how the router will know that to which system it is going to send the file, because it knows the IP address of your system, Ashwani. Okay, that is the meaning of IP address. It is an internet protocol address, which is an address of a particular machine. What is machine? Machine, your computer only. A simple computer, suppose I'll just write my IP address.com. Okay, you guys can have your own IP. So if you want to know what is the IP address of your system, you can go to the what is my IP address, or then you can just click here. It's going to display a IP address of your system. This is the IPv4 address of my system. So there are two IPv4 and IPv6 address are there, which we are going to discuss ahead. But each system has their own IP address. This is my system IP address. The same way, if you want to cross check yours, you will also get the IP address of your system. So it is just an address. It is just an address, guys. So address of your machine. So each machine, like every machine in the world, has an IP address associated, because that is the address. So tomorrow, if I want to send some file to a particular system, okay, if you want to send a file to a particular system, then you should know the IP address. Yeah, how to create the IP address? These IP addresses I will tell you. And money, okay? Wait for some time. There is a process I will tell you. So now, guys, this is a pure example of your IPv4 address. There are two IP addresses are there, IPv4 and IPv6. Okay, so IPv4 were introduced, before IPv6, because IPv4 are are your octal representation. So let me just take out one, what is it? I have one diagram that will help you to understand the IP addresses. Okay, let me open that. Okay, I told you there are two type of IP addresses, guys, IPv4 and IPv6. So this is an example of IPv4 address. So IPv4 is having 4 bit, guys. So these are all different bits. Look at 10.0.0.0.0. So these are 4 bits. Each bit is having an octal value. If you go, go through your math concepts, there's a form of octal representation. Like when you convert your binary to decimal, so this is how you're going to get. So in the same way, look at this. This is your 4 bit, and each bit is a octal representation. That means 8 values, 8 bits are there. Now you will say, what is this 1 and 0? So 1 is your on bit and 0 is your off bit. So when you will be calculating your IP addresses, wherever there will be a 1 inside a bit, that you are going to calculate. So let me just tell you, okay, for the look at this example. Suppose if you want to calculate the IP address of 10.0.0.0, so look at this. I told you this is a the 4 octal representation. This is octet 1, octet 2, octet 3, and octet 4. So total is 4 octets, and each octet is having 8 bit. So total how many bit are there for IP address? IPv4 total 32 bits. IPv4 is a 32 bit IP address. Okay, and now look at this. I was telling you about 1 and 0. If suppose there are all 1 bits are there are 8 bits from 0 to 7. If suppose all bits are on, 1 is on, 0 is off. Okay, if suppose all the bits are on, then how you can do this binary to decimal conversion, guys? Okay, Sonia. Hey, what about others? Can you hear me, guys? Sonia is telling my audio connection is lost. Sonia, others can hear me. Please try to reconnect. Okay, Sonia, please try to reconnect. Okay, so look at this, guys. So there are 8 bits are there. So how to do binary to decimal conversion? In math, it is very basic. You do 2 to the power of 0, 2 to the power of 1. So let's consider this is 2 to the power 0, the first bit. Second is 2 to the power 1, and so on. Till 2 to the power 7. 2 to the power 0 is 1. 2 to the power 2 is 2. 2 to the power 3 is 4. So 2 to the power 0 is 1. 2 to the power 1 is 2. And 2 to the power 2 is 4. So on. We got 2 to the power 7 as 128. If you will combine, if you will do the addition of all the bits, then you will get a bit of a particular octet. So the maximum value of a particular octet is going to be 255. 255, you will get the maximum value, the maximum range. It is telling each octet range will be between 0 to 255. So 255 is maximum. When all these octets, like all these bits are 1. When all these bits are 1, then you will get the maximum value of 255. Suppose if you want to check out the value of this, 10. How? If suppose this is the IP, suppose just a minute, yeah, 10 dot 0 dot 0 dot 0. Okay, how you will come to know, okay, how this, how we got this bit. So I've told you there is a, there is a, each particular bit is a octal representation. So if you will do like suppose 0, these are all bit, okay, 0, let me just put first 0 over there, okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now, we have to on the bits. Currently, when everything is 0, if suppose I have to calculate this 0, how we got this 0? This means all these bits, okay, all the 8 bits of this particular octet will be 0. That's why 2 to the power 0, like when you will multiply 2 to the power 0 with anything, it will come 0 only. So because all the bits are off. But for 10, okay, here some bits will be on. That's why we got this 10 value of a particular octet. How we got? So look at the diagram. Okay, so here the second bit would be on. So this one will be 1. Okay, and look at this. Where is 8? 8 is here. So this also will make it 1. Now let's calculate from here, okay, 2 to the power formula. So for example, if I will calculate 2 to the power 0 with 0, it will come. What it will come? 2 to the power 0 and 0 is your 1. Just a minute. 8, 4, 8, 9, 10. I think I've done some error, guys. Just a minute. Before 8, 9, 10. Okay. Yeah, correct. Okay. So this bit is off. I've told you, Manish, this each bit here is an octal representation. 10.0.0.0 is your total IPv4 address. Each bit is your octal representation. Octal means 8 bits. Okay, and these are the 8 values, like 0 and 1. These are the 8 bits, guys. Look at this for a single octet. Now we have to find how this 10 was formed here. So to get there, look at this. I have written this, okay, this value. This will create a 10. If you will multiply by 2 to the power 0, so when I will do this first bit is off. So 2 to the power 0 is 1. So 1 into 0 will be 0. Now let's come here on the second bit. 2 to the power 1 is 2. And multiply by 1 is 2 into 2 into 1 is 2. Now the third bit is 0. So we won't be calculating any 0 bit. So now we'll come to the 2 to the power of 3. So 2 to the power of 3 is 8. 8 into 1, since this is the on bit, we are going to calculate with 1. So it will come at 8 and all the other value will be 0. This is a simple mathematics. Your binary to decimal conversion. This is how we are converting binary to decimal. So binary is having only 2 values, 0 and 1. 0 means off, 1 means on. So for all the 0, I am not going to calculate anything. But for 1, I am going to add the values. Okay, guys. So the same way, now look at this. Where we got one under this 8 bits, one it here at 2 to the power 3, and other one is at 2 to the power 1. So 2 to the power 3 is 8, and 2 to the power 1 is 2. Now I have to calculate now I have to add everything, okay, to get the value. Well, just add everything here. And what I will get the value of this particular bit, that is 10. Okay, so now you got, this is a simple binary to decimal conversion. Each bit is an octal representation. Octal is having 8 bits. Octal means 8. That means 8 bits. So the maximum value can be 255. How? When all these 8 bits are 1. If suppose all the 8 bits are 1, then what will be the value of this particular octal? It will be 255. That will be the maximum value, because that is your maximum, because all the bits inside a octal representation is 1, all are on. So when I'm going to add this 128 plus 64, 32, 16, 8, it will come 255 as a total. And minimum is 2, if minimum is 0. So suppose if I want to calculate some, like how we got this 0, that means all these bits inside octal will be 0. If suppose I'm multiplying something with 0, I will get 0. But here we were calculating how we got this 10 over here. So to calculate that inside this IP address, I first form a binary. How the binary is going to look. So this will be the binary form. So here in the binary, now I am starting from here. From left to right, from right to left, I am starting. So the right width is 0. So the first one we will start with 2 to the power of 0. 2 to the power 0 to 0 is 0. Now 2 to the power 1 is 2. 2 into 1 is 2 we got here. Here we got, okay. Now the third is 0, which is off bit. We are going to make it 0 itself. Now let's move to 2 to the power 3. Now 2 to the power 3 is 2 into 2 into 2 is 8. 8 into 1 is 8. So we got 8 here. Apart from that, all the bits were 0. So it will come ultimately 0 here. Now I'm going to add all these, all these bits to get the value of a particular octet. So now I have added 8 plus 2, that is 10, because all the other bits were 0. So that's how you will come to know how to calculate a single bit of a particular IP address, like single octet of a particular IPv4 address, guys. Is it clear? Let me just, Is it clear now? Okay. Okay, great, guys. Okay, so this is how. So tomorrow, if suppose I will ask you to, to just calculate, like a particular IP address, or some other stuff related to the network, you should be able to tell me the answer. Okay, so this is all clear. How now you know what is IP address? It is a representation of 4 octal. Total how many bits? 32 bits. We are talking about IPv4 address. That is 32 bits. And now what is IPv6 address? IPv6 address are advanced IPs, okay, which are of 128 bits. In next slide, I'm going to tell you. Okay, so let me just go to the next slide now. Now you understood what is this IP, what is this octal, and what is these are all octals, and these are all the bits. With that, once you will add these bits, you will get this value. Suppose for 192, this will be 128. This is going to be 64. 128 plus 64 will be 192, because other are 0. For the 0, everything should be 0. That's why this bit is 0. Now coming to the third octal, which is 2. So here, if I will see the binary representation, only 2 to the power 1 value. The second bit of octal will be 1. Apart from that, everything will be 0. That's why we will get 2 here. Now again for 0, all the bits inside octal will be 0. And that's how you can calculate the IPv4 addresses. Okay. So now I was talking about what is IPv4 and IPv6 address. So IPv4 is a 32-bit address. This is the example which we have just now seen how to calculate also. Now comes to IPv6 address. These are a bit, like advanced IPs. So what was happening, guys? Okay, these IPv4 addresses were becoming shorter. Since these IPv4 addresses were introduced way in 18th century. Okay, from there slowly people are using these. But at one point there was so much machines in the world. Have increased in the world. The scientists were, these computer scientists, were thinking that one day these IPv4 addresses will be, will becoming short. each machine won't be able to get the IPv4 address, because 32 bits can only get something around 3.2 billion IP addresses. And today, like how much is the total population of a particular, like, or like of our, Earth. Okay. And if suppose if everyone is having one laptop, each individual is having one laptop, then it will be becoming problem to to have to assign a single IPv4 address to each machine. So that's why, to come over this challenge, so that IPv4 addresses should not be shortened, they came up with IPv6 addresses, which are more advanced addresses, like 128 bit. The purpose is same. The purpose is same. This is also solve the same purpose. It also map a particular IP to a machine, so that you will come to know that this is the address of a particular machine. The functionality and the purpose is same, only the representation is different. If suppose tomorrow, if you will see any example of this particular IP, which contains both alpha and numeric, and these are in between you will get colon also. Here you use dot, but in IPv6 you use colon. So if you are getting this kind of a IP, then you will come to know whether it is IPv4 address or IPv6 address. This is an example of IPv6 address. And for IPv6 you can't calculate these IPs normally, like I've told you how to calculate IPv4 addresses manually. For this you need one IPv6 calculator. If you search on the internet for IPv6 calculator, you will get, and from there you will come to know how, you will get these IPv6 addresses, IP addresses. From there you can calculate. Okay. So Naren, is it clear? You are telling once again, explain. I think it is clear now. Naren, that IPv4, how to calculate the IPv4, is it clear? I can see in the chat. Yeah, okay. So now what you have to understand here, what is the difference between IPv4 and IPv6? First of all, IPv6 is 32 bits. It is a 4-octet representation. And IPv6 is a advanced, what is it, like it is an advanced IP address system, which is of 128 bits, and this is how they look. IPv4 looks like this. This is an example of IPv4 address 192.0.2.0, and this is an example of your IPv6 address, which contains your alphanumeric, and which are which are segregated with the help of colon. And why IPv6 came into the market? Because there was a shortage. In future there can be a shortage of IPv6, because it can only generate around 3.2 billion IP addresses. That's why scientists thought, let's bring one more address system, so that there should not be any shortage of IPs in the world. That was the only reason to bring the IPv6. There's nothing like, there is no other advantage of using IPv6, that it is good in network and all. That is nothing is there. Only it is the purpose is to get IPv6, because there was a shortage of IPv4 in the in the computer world, I would say. That's why. But if I will tell you what is the main difference between IPv4 and IPv6, it's only about the bit. IPv4 is 32-bit address, IPv6 is 128-bit address. That is the main difference, guys. Okay, now you understood what are the two kind of IP addresses, IPv4 and IPv6, and now you also know how to calculate the IPv4 address. That also you understood. Okay, now let's move to one more concept before deeping dive into the VPC part. That is your CIDR block. CIDR block, also known as classless inter-domain routing block. Okay, it is the abbreviation of CIDR, classless inter-domain routing. So it is used to allocate a IP range to your VPC. So whenever you will create a network, you're going to use an IP range. Range means, suppose, inside your IP range, there are 10 IPs. So that is your IP range. I will tell you how to calculate the IP range also. So the CIDR is used to allocate these IP ranges inside to your virtual private, to your VPC, virtual private cloud. So now how to do that? Let's check out. Okay, first let's understand this. I will share you one more. Just a minute. I will just open one more example. Okay, it will help you to know how to calculate. Okay, so understand this. So for example, let's understand here. This was one IP address. Okay. So just a minute. Okay, let me open this. Okay, suppose this was one. This is the example of a CIDR block. Suppose this is the CIDR block, then how you will calculate that how many IP addresses are there. So let's calculate one IP address, CIDR block for one VPC. So how to calculate that? Let's check out. Okay, let's calculate CIDR block. Okay, let's calculate the CIDR block for 10.0.0.0.0 divided by suppose 24. Now you will ask me, what is this 24? This is known as divide by 16, or 24 is your network prefix or network masking, which means if I'm telling, how much is the total bit of your IPv4 address, it is 32 bit. So this network prefix here, if I'm telling 16, this means it is going to fix the 16 bits. The first 16 bits will be fixed, and now whatever value we are going to assign to create an IP address range will be, will be manipulated inside the last 2 bits. So this is a network prefix, which is also known as network masking. We are going to mask this network to create the IP range. So whatever value we are going to define here, suppose I am defining 16, or suppose if I have defined 24 over here, that means I am fixing those bits. 32 bits are there. Inside those I fixed 24 bits. Now on 8 bits only I am going to create an IP range. That is the meaning of submasking. So the minimum value is 0 and the maximum value is 32, because here we are masking the IPv4 address. So we all know the maximum value of a bit is 32 because it is an octal representation. This was an octal representation, guys. This is one octal, this is second octal, third octal, and fourth octal. Each octal is having 8 bits. When you will calculate 8 into 4, it will come 32 bits. So here also, the maximum value of this network prefix will be 32. And what will be the minimum value of this network prefix will be, you can say 0. Okay, that will be the 0. So let's consider a between range. That is, if suppose we have got this CIDR block, we have to, you got a requirement from the client that we need a CIDR block of a VPC. VPC is this 10.0.0.0 divided by 24, and now based on that you have to calculate how many IP addresses you will get, because within the CIDR block only, whatever machine, suppose you have you have launched 2 EC2 machines inside your VPC, so those machines will get these IP, IPs only. The IP range starting from this 10.0.0, and then there will be some difference here, 1, 2, 3, 4 as per the range. So let's first calculate here. So as per the formula, okay, don't go for this example because it is going to give you lot many IPs. So we are going to go with a simple example. So this first it is telling total available host bit. So first we have to calculate what is total available host bit. So total available host bit will be. So what is the total bit? What is the total bit of your what is it what is the total bit of your octal representation for your IPv4 address? It is 32. So total bit will be 32. Total bit is 32 now. Yeah. Okay, now it is telling minus network prefix. So here, what is the value of network prefix? It is 24. So what will be the result? 32 minus 24 is 8. That is the first thing we have to calculate using the formula. Now what is the second step of the formula? Now we have to calculate total available host bit. Now we have to calculate total available IP. So first we have calculated what are the total available host bit. So here we got 32 minus 24. 24 is your network prefix. 32 is the total, IPv4 bits. That is 32 for octal representation. So here we got 8 bits. Now what we have to do? Now we have to calculate the total number of IPs. So total available IPs will be 2 to the power of 8. So what is the 2 to the power of 8? 2 to the power of 8. As per the formula, it was telling 2. This is the power sign, guys. 2 to the power total available host bit. So here, how much bit we got total as a total available host bit? We got as 8. So now we have to multiply is at 2 to the power of 8. So if you will do this 2 to the power 8, you will get, I think, around 250 6. If not, let's check out here, okay? Like for this 2 to the power 8, you can also use this 2 to the power 8. You will get some result. Yes, it is okay. It is 256. The same. So that means this particular CIDR block will have 256 IP range. That is your VPC. So suppose if you are launching 200 server, those all will be launched with this particular IP address range. Within this IP address range, all these servers will be launched. So once you will do this experiment VPC, once you will do the demo also, I will show you the demo, then it will be more clear. But here, what main thing I want to explain you, how to calculate this CIDR block, because that is important. You will get the requirement, and you maybe in the future you have to calculate this, this, that how many IPs are supported within a CIDR block. Okay, so let me just test you now. Okay, suppose this is our IP address range divided by 28. Now tell me what will be the total bit size here. Use this formula and tell me what will be the total host bit. Tell me what will be the total host bit now here. If I'm using this for the CIDR block, I want to calculate the number of IPs. What will be total host bit? Okay, so total host bit, somebody told me it is 4. That is correct. Total bit will be 32. 32 is our total number of bit of IP address, and minus submarking. How many bits we are fixing? 28 minus 28. It will come as 4 bit. Now, what will be the total available IPs? Total available IPs. Don't unmute, guys. Please put it your answer in the chat. I'm constantly checking these chat. Okay, your answer. So total available IPs will be 2 to the power of 4. What is the value to the power of 4? 16. So now, if suppose I am launching 10 servers inside this particular CIDR block, all will be having this particular kind of a IP range. Okay, and this is your private IP range. With the help of CIDR, you calculate the private IP range. Your public IPs are assigned automatically. I will tell you what the difference between public and private IP. But with the help of CIDR, you calculate your private IP ranges. Okay, private IP range is calculated. How will the masking start, sir? From the left side or the right side? From the left side or it will go the same way. From the right side it will start. First it is going to fix the rightmost value. They are going to fix the second rightmost. So from right to left, the masking is going to start. Okay. Okay, so I hope now it is clear how to calculate your CIDR block and how to check the each bit of a particular IP, IP address. Is it clear? Okay. What does it mean by total 16 IPs? So it means that this CIDR block will be given to a particular VPC. So VPC is a network slotted. So inside that network, you are going to launch some machine. That's why we are creating the network, because on those machines or instances, your application will be hosted. So that machine will have an address. It is going to have an address. So that address will come from this IP range. So suppose this is the range of an IP, that 16 IPs are there. So maybe, if you are launching any server within this IP range, 10.0.0.0/28, then maybe you will get this IP of a particular machine. Suppose instance 1, suppose you are launching 2 instances. So for instance 1, you will get this IP 10.0.0. Maybe 5, and for another instance, for instance 2, you will get IPs 10.0.0.0.7 to assign, because this is going to assign an address to your system. So it will automatically. Now many are asking me how these IPs are assigned to a particular system. It is assigned automatically. Once you will create a network, once you will create a network and you will launch the instance, then automatically it is going that each instance will be mapped with the IP within the IP range, within the CIDR block, which you have defined. So this is your CIDR block of your VPC. That means if you are using the CIDR block, 16 IPs will be the IP range. Your VPC will have a 16 IP range. So if you're launching 2 machines, 3 machines, 4 machines, all will be having the IP associated with this particular IP range only. So I'll give you an example. Suppose you are using this particular, this CIDR block, and it is giving 16 IP. Suppose you are launching 2 instances here, you will get the IPs associated like this, and these are your private IP addresses: 10.0.0.5, 10.0.0.7. These are the IP addresses which are associated with your machine. So CIDR block is used to calculate the private IPs range. Now you're clear, Salate? With the example, now you got the purpose. No, it cannot be. It could not be. Yeah, very good. It could not be. .70. It could not be. Yes. Okay. So now somebody is asking me, what is that? Money, I've told you, this is your masking. This is a network prefix, also known as masking. This component tell you how many bits are fixed. This is the part of a formula. Okay. So you have to divide your IP with the help of network masking so that you will get a CIDR block. Okay. So, money. So if suppose I am using this 24 bits, okay, that means the first 3 bits I am making it fixed, because total we have 32 bits, and each of this value is a single octet. So 24 means 3 octets. The first, second, and third bit will become fixed. All 3 octets will become fixed. Now, whatever IPs will be, whatever IPs will be assigned to your particular, EC2 machine will have this last digit will be manipulated. Maybe like if I'm using this particular CIDR block, then what kind of instances I will get? Maybe I will get instance 1 as first instance as 10 to the power 0.0.0 244. The second as 10 to the power 0.0.156. How many bits we are fixing? That's a part of the formula. So here in the second example what I have given you, here they are fixing 28 bits, and now the movement will be on the that means the first 3 octets are fixed, and inside the last octet 4 bits are fixed. So maximum we will have 16 IPs over here. Maximum we will have 16 IPs. So this will be your instances. This is an example of instances which will be launched inside this particular CIDR block. The same way, if I will take this example, guys, let me take this example. Here they are telling divide by 16. Divide by 16 means the first 2 bits are fixed, because 8 and 8 plus 8 is 16. Now whatever IPs will be assigned will have different values of last 2 bits. Look at this. Here you will get around 65,536 different IPs inside your VPC. So if you want to have that great IP range, you can use this also, where you can launch different around 65,536 different machines you can launch using this IP range. Okay, 32 is constant. 32 is a value. Yeah, if the 32 is there, that means only a single IP. If suppose I will make it as 32, that means only a single IP, because if I will use here 32 if I will use, then we will get only 0 bit, and 2 to the power 0 is 1 IP. So this will be your IP. 10.0.0.0 will be the single IP address. Okay, so that is the maximum. That is the maximum constant we have, 32. Now somebody is asking me, sir, can you explain IPv4 in short? IPv4 is an address. Okay, Ashwani, like it is a simple, like it is the address of a machine, and IPv4 is having your 4 octets. Each octet is having the 8 bits. So total the value of the number of bits an IPv4 contain is 32. Now Nitin is asking me what is the difference between CIDR and subnetting. Actually, Nitin, CIDR block, okay, CIDR block you assign to VPC. CIDR block you assign to VPC. But suppose, hey, 2 to the power 0 is 1, money. 2 to the power 0 is 1, money. Don't, I'm not here, I'm not a math teacher, but if you check out, okay, don't ask me that kind of a, question. You're challenging maths, okay. Look at this. 2 to the power 0 is 1. Money, please revise your math concept. Please. Okay. Look at it. 2 over 0 is 1. Okay. Now I think it would be clear for you. I think that was the doubt. Now, Nitin, I will just come to your answer. Very good question. Actually, what happens? You will, you can assign the CIDR block to both VPC and subnetting, or to your subnets. So subnets are also a smaller, a smaller IP range. So suppose this was the IP range of your VPC, Nitin. Now you can create the subnets. So you can, so you will also assign a CIDR block for subnet also. So there is no difference between CIDR and subnetting. Both are same thing. But CIDR, you associate a CIDR with both VPC and subnets. You got it now, Nitin? Is it clear? CIDR is used to create a IP range. Subnet is used to, it used to divide a large network. So once I will go to the subnet, once I will explain the subnet, Nitin, then you will automatically get the difference. Okay. But what I want to tell you here, how to calculate CIDR, that is clear, because that is important. And what is, how to calculate each bit of IPv4, that is important. If that is clear, we'll go ahead. Okay, guys, is it clear now? Because these calculations I have to show you, because these are very important. So tomorrow I'm going to ask you, okay, how to calculate the range. So I want, answers from you guys, okay? Please. Okay, so let's go ahead now. Let's go ahead. Okay. So this is clear now. Now, let's understand this OSI model. So what is this OSI model? So OSI is your Open System Interconnection Model. So this is a model, this is a network model which has been created, which is having multiple network protocols. Network protocols are the set of rules which define the security of your, of the information which is traveling to different network layers. So inside your, this OSI model, we have 7 layers. This is a 7-layer model. So the base layer is physical. Then we have data link layer, network layer, transport layer, session layer, representation layer, and application layer. So all these 7 layers are combined together, and they make a open system interconnection, that is your OSI model. And this OSI models will tell you how the data will be traveling, across each layer of this OSI model. So both how the once development application is going to generate the data, then how the data will be traveling to presentation layer, then to session layer, then to transport, then to network, data link, physical, and then it will move to the your recipient machine. There is a sender and receiver. So how the how the data is getting sent through this different layer is the representation of this OSI model. How you're going to send a data across these 7 layers. So let's discuss all these layers, okay? And with each layer, we are having one protocol. So I told you, what are the protocols? Protocols are the set of rules which are used when you're exchanging this information on the internet. These protocols provide some kind of a security to your particular, to your information which you are exchanging over the internet. Suppose I am sending hi. Suppose just now you guys are asking the question. Okay, so that from your machine, that information is coming to my machine. I can see that. So that's how the data is getting flowed. So you are the sender, I am the receiver. I am receiving all your messages here. Somebody is asking what is difference between XYZ. Somebody is asking some other question. So how this data is getting transmitted to this OSI layer, we are going to discuss this. Okay. So the first one is your application. So on the application layer, it is an application which generates and sends the data. Suppose currently we are on a Go webinar. Let's talk about the tool which we are using now. So Go webinar is a tool. So from your machine, you have generated something like you have written what the difference between IP and CIDR. Nitin has written. Now once Nitin will press enter, that means he has sent that information over the network. Now that information will come to me. It is going to come to my machine. Okay, it is going to come to my machine. So that whole data, how it is getting traveled to all these 7 layers, that is the representation of OSI model. So this application inside Nitin's machine is the go-to application which has generated the data, that is the question, and it has sent to me. It has sent over the network. So application layer is mainly responsible for generating and sending the application data. Now From this layer, the data will move to presentation. So currently I am speaking, I am taking this example on the reference of sender. Suppose there is some sender, like Nitin is a sender who is sending one message to receiver, and I am the receiver machine. I am getting his message. Okay. So we are now discussing in the perspective of Nitin, who is the sender. So Nitin has sent one message to an application. So what was the usage of this application layer? It has generated the message and then it has sent the application data or the message. Okay. Now, and now second, the data will come to the presentation layer. Now the data is going to come to the presentation layer. Nathan, first, check out this OSI model. Then I'm going to answer you this DSCP one. Okay, afterward. Okay. Actually, inside the application also, when you will go to the deep network, we have different kind of a component also, like DSP, DSP. But I'm just talking about in general, what is the use case of each and every layer of OSI model, how the data gets transmitted. Okay. So now after the application, once the data is now generated and it is sent over the network, now it will come to the presentation layer. So inside the presentation layer, inside the presentation layer, the format of data will be changed. So there will be a format in which the network data will be traveled. So it is going to change that high level. Suppose one message was sent from Nitin, differentiate between CIDR and subnet. That was in high level language, that is English. Now that will be changed to the some neural networks or some like networking kind of a networking kind of a format that will be changed. So at the presentation layer, it is going to change the format of your data. It is going to change the format of the data. Secondly, it is going to encrypt your data. Here the encryption will happen so that in between nobody can hack your data. So what is the purpose of presentation layer? Once the data will be transferred from application to presentation layer, at presentation layer, first of all, the data will be changed to another format where it will be helpful for for moving the data across the network. And second is going to encrypt the data. The data will be encrypted. Now that data will be moved from presentation to the session layer. So inside the session layer, one session will be created. Like currently we are having one session. We are having one session of 2 hours each. We have one session, so that for 2 hours we will be connected to each other, and we are going to discuss the AWS topics. After 2 hours, we are going to disconnect, and tomorrow we are going to create a new session for 2 hours where we are going to connect. Like that, there will be a session which will be created between sender and receiver. So why we are creating the session? So that one session will be active, and until and unless all the data will be transferred from sender to receiver machine, the session will remain active. Once the data transfer is completed, then only this session will be terminated. So here, this session will be created and this session will be active till the time the exchange of data between your sender and receiver is happening. Once that exchange is completed, then the session will be terminated. Now from here, once the session has been created, now the data will be moved to transport layer. So under the transport layer, your data will be divided into a small segments. So currently there was a huge data. Okay, suppose the data is now we got a high level data, and the data was transmitted to binary. Then now it is under the network. And suppose under the network, that whole data. Suppose there was a huge message. Differentiate between CIDR and subnet. Now suppose we are dividing this message into a small segment. Like difference between in a first segment and CIDR in the second segment and the third segment and subnetting. So we are dividing the data into a small segment that happens at the transport layer. Okay, and apart from that, it will also store the sender and network IP address details here also. It is going to store here at the transport layer, so that it will come to know where exactly routing is going to be happen. And now under the network layer, we are subdividing these packets into into your smaller packets. Previously at the transport layer, the whole data was divided into the segment. Now those segments are further divided into the packets inside the network, which are known as network packets. Now why we are doing this dividation? We are doing this dividation so that, for example, suppose sometimes some network disruption happens, guys. So suppose there was one huge file of 1 GB which sender is sending to receiver. Now suppose in between, suppose in between, suppose if we are not dividing the whole data into a different segment or a network packets, then what problem will occur? If suppose 1 GB file was getting transmitted from sender to receiver over a network into a single way. We are not dividing anything. If we are not dividing that file into a smaller segment or packets. So suppose in between some network disruption occurred, and at the time half of the file got transmitted. Then too, when the network disruption will get over, a new network will be connected. Then this file will be sent again. So lot of time wasting is there. You got it? If I am dividing that whole file into segment and small packets, then those small packets will be transferred. Those small packets are going to be transferred to from sender to receiver. And in between, suppose some network disruption happen, then you don't have to resend the packets again. Whatever packets were received by the receiver, you don't have to resend again. That is going to save your time. So once the network is disruption is over, you are connected to the network again, then whatever remaining number of packets will be there, that will be transferred over the network. That packet contains your data, and that data is divided into a smaller packets. First of all, a smaller segment, then to the smaller packets. So now once this is done, after that the data will be moved to the data link layer. Now inside the data link layer, all these small packets which you have divided of a whole information is going to reframe, because at the end of the day, at the at the other end, the receiver is going to get the whole 1 GB video. That's what we can see. Or suppose this is sending one message differentiate between CIDR and subnetting, that whole message will be sent in a singular way to my machine. It won't be into a smaller smaller packets. So that, how I will understand it will come to a smaller packet, how I will know which will be the first packet, which is the last packet. I have to make a lot of puzzles to get a singular message. So now at the data link layer, what is going to happen? The message which was into a smaller packet will be reframed there. So it is going to reframe the whole message. Suppose the message differentiate between CIDR and subnetting was in a smaller, suppose 100 packets, 100 small network packets. Now it is going to reframe the whole message at data link layer, and also it is going to check out whether the whole data is error free. That means, is there any single packet is there which is missed? It is going to check everything so that the whole message should be error free. There should not be any error in the message, because now from data link we are going to send to the physical layer. Okay, so at data link, what we are doing? First of all, we are reframing all the packets to get a single data, and we are checking that the whole data should be error free. Whole data should be error free. Secondly, what we are doing, we are also here, this data link layer is going to maintain the data speed between two machines. Suppose Nitin was a sender. Nitin is using a very high internet of suppose 5 GB per second speed, 5 Gbps. I am not using that kind of internet. I am only using 1 Gbps. So there is some difference in the speed is there. So the data link is going to maintain that speed automatically. We are not going to do any config. We are not configuring anything over here. This is going through automatically to OSI layer. I am just going to explain you each and every layer. I am just explaining you how the backend works. So for data link, okay, it's going to maintain the speed. Suppose from here, the speed is high, so it is going to lower down the speed of your data, so that it is going to maintain the speed between both machines, so that the transfer of the information will be smooth. Now, from the data link, the data will be sent to the physical layer, which is the last layer. Here, the data is converted back to the binary form. From binary form, it is going to be sent to the sender's machine through these all layers. So this is how the data is going to travel from your sender machine through application to presentation to session to transport, from transport to network to data link to physical, and in the same way from down to up, it is going to be sent to your this receiver machine. So now receiver will get the data at physical layer. From physical, it's going to be sent to data link. From data link to network, transport, session, presentation, and your application. Okay. Okay. So it was this will all happen. No, this will be happening is that how your data is getting traveled. Like currently you have sent You have sent me the data. You have sent me the data. You have sent me the data here. Okay. So the description of the data. Okay, Sandeep. First, I will answer the money question. Okay. So money is asking how this will all happen. So currently, you have sent me this message. This all will happen inside. So you send me one data over the network. So data has came through all these different layers only. Okay. Okay, so now somebody is asking me what is the description, decryption. Now the same way, you know, I told you this is a representation of sending the data, Sandeep. Now, like in the same way, receiver is going to receive the data. Now, when the data will come from, first the data will be received at receiver machine at physical layer, then will move to data link, network, transportation, session, and finally at the presentation. Once it will go to presentation, the data will be decrypted, Sandeep, and it will be then finally it will be sent to application layer of the receiver machine, and I can see your message in the okay. Okay, Shivam is asking explain presentation and transport again. Okay, so presentation layer first of all is going to convert the data in different format. With that format is going to travel through the network layer. It is going to change the format of the data. So suppose we have written the data in a high level language. So it is going to transform that into some lower level language, which is used to in that format the data will be flowed to different layer. That is the first use case of presentation. Now the second thing of presentation layer is it is going to encrypt the data. The data which you are sending, that will be encrypted. Now so that is the main purpose of presentation layer. Now the second thing is what is transportation. So under the transport layer, your data will be divided into the segment. Suppose there was a huge data that will be divided into small segment. That is the that is the use case of your transport data. A transport layer. Inside the transport layer, it will also have the IPs of your sender and receiver machine. So it is going to route those segments to the correct machine. You're going to route those segments to the correct machine. That is the two use case, two functionality of the transport layer. Segment means small segment. Suppose how I can tell you, you are dividing a whole message into a small segment, a smaller form. That's it. Segment means a smaller form of data. A whole data is divided into a smaller segment. Okay. Yeah, Shiva. A transport layer, we are dividing the data into segments, and those data is further divided into packets under the network layer. So those packets are a smaller form of segments. First the data is divided into segments, it is further divided into packets. Okay. So now Nitin was asking me, introducing me LDAP. LDAP, these are some your question which you are asking me. I'll tell you LDAP is a it is a directory, Nitin. Okay, it is your active directories are there. So that is a different part. And under these LDAP directories, you are going to suppose you are working in an organization. In your organization will be using this Microsoft LDAP directories. Inside that, all the information of your of all the employees will be centrally placed. That can be accessed centrally all over the world. That's the meaning of LDAP. Second, ASCII. ASCII is the American standard of code for information exchange, which is a way how the information is exchanged over the internet. They created the ASCII codes. So ASCII codes are there. With the help of that, the data will be created, which is understandable by the machine itself. So machine don't understand the data in high level language. Like suppose they understand the data in this ASCII format. So it is a format where with the help of that computer machines understand the data. Now you're asking me what is this RPC. RPC, can you just tell me the full form of RPC? And net BIOS are the internal these are the very internal networking concepts. I'll tell you net BIOS, and I'll just tell you what is RPC. Also, I have never used that term. Okay, RPC. You can tell me what is RCP. I'm going to explain you that also. Net BIOS and RCP I will explain you after the break. Okay, I'll just set out. Okay, now Mani is asking what is converted into segment and which is how it will come into the segment, which and how it will be converted into the it will be converted automatically. The data, you are not defining these layers, Money. It will be automatically converted. So once the data will move from this layer, it will automatically having the algorithm at each layer. It is going to automatically divide the data into the different segments. From segments, we will divide into the different network packets. Now, Rishikesh is arguing for center, the data will flow from top to bottom, and response will be from bottom to top. Yes, Rishikesh, it is correct. Okay, I think I've answered everything. Only for Nitin, I have two things open: NetBIOS and RPC. I'm going to explain you because these are all core network topics. Okay, so I'm going to tell you NetBIOS and RPC after the break. Apart from that, everything is clear and all the questions are answered. Okay, guys, let's go for a break. I hope now this OSI model is now clear to you. How the data is getting transferred from different layer, it is clear. What is the purpose of each layer? That is clear. Okay, and Nathan, I have two things are open from your end that I'm going to answer you today. Okay, RPC and NetBIOS. Okay, guys, let's take a 5 minutes break. It's already 8:50. After break, we're going to check out the other concepts. What is VPC? Okay, thank you. Okay, guys, welcome back. Okay. Okay. So now we will start with section number two. Okay, that is our Amazon VPC. I hope I'm clear. You are able to hear me well. Okay. So Nathan, your two questions actually those are all networking concepts. Okay. Being a solution architect, these are all advanced networking part. You won't be only working as a network engineer. I'm going to answer two things: net BIOS and RPC tomorrow because I have to check out that part. Okay, net BIOS and RPC because as a like a solution architect, you should know how to create the infra and different components and all these settings. All these net BIOS RPCs are the in configurations which are done at all those these layers. All these network engineers are there to work on these layers. So on like suppose on the session layer, your net BIOS, we have to change the settings of net BIOS. So it enables to machines to communicate with each other on a LAN, on a local area network, like over the internet also. The same way we have RPCs also there, which is also a protocol. So these are all deep dive networking components I'm going to tell you tomorrow because I'm not a network engineer, and these are all networking kind of questions which I'm going to tell you tomorrow. But as a solution architect, you won't be asked to make the configuration of these stuff. Okay, inside the OSI layer, you will be having a dedicated network team which is going to take care of that. You have to build the infra, so that we are learning here. But then too, these two things, NetBIOS and RPC, I'm going to take on. I'm going to have a deep dive on this. I'm going to tell you tomorrow. Two things are open from your anything. I have make a note of that. Okay, so you get an answer tomorrow for those two things, NetBIOS and RPC. Okay, so now this is clear. Okay, the how the working of OSI happens, how the data gets traveled from one layer to other layer that we have just now seen. Now let's understand what is Amazon VPC. So Amazon VPC, it is an isolated, logically isolated section of the AWS cloud where you can launch AWS resources under the virtual network which you have defined. So main thing, with the help of this Amazon VPC, with the help of Amazon VPC, you're going to create your own network. That is your virtual network. Now inside that virtual network, you're going to define your own AWS resources. So till now, suppose you have not created any VPC. So Amazon already creates a default VPC in every region. So suppose we have different around 22 regions are there inside AWS. 23 regions are there. So for each region, our default VPC will be there. So suppose you have not created any VPC, then your EC2 instance, the machine which you are going to which you are going to launch will be created inside a default VPC. Let me just show you the default VPC. Suppose let me log into my AWS account. Amazon. Let me sign into the console because till now, if like in any region I have not created any VPC. If when I am not creating any VPC at that point of time, we already have a default VPC is already there. But you understood what is VPC? It is an logically isolated area. Okay. Inside that, you will create your own virtual network. You're going to define your own virtual network. And inside that virtual network, which is created with the help of VPC, you're going to launch your AWS resources for hosting your application. Okay. So suppose let me go to the EC2. Let me show you. So we are under the Mumbai region. And so let me go to the instance. Let me click on launch instance. And let me select this. We will come to this once we will go to the compute section, then we're going to explain you all this stuff. So suppose here, once we will come to the configuration, look at this network. So currently there is one default network. This network is your VPC. So once I will create my own VPC, then that VPC will come into this list, guys. And then I have to select my own virtual network to launch AWS resources. So by default, AWS already has the default VPCs. Okay, already have the default VPCs. but we create our own VPCs because the default VPC doesn't have like the security walls and all. Like it is a default. You can just launch instances, but to make your own isolated area, we have to create a VPC. Inside that, we're going to launch the EC2 instances and other database, like databases, web server, application server. You can create the whole instance at a particular VPC. Okay, so now it is clear what is VPC. Let's check out some more stuff. Okay, so now it will give you control over your virtual network resources. Once you create your VPC, you will get a control over your virtual networking resources. First of all, selection of IP addresses. Same way I've told you, once you create a VPC, you have to assign a CIDR block. Suppose you have assigned a CIDR block of this, suppose of this CIDR block you have assigned to your VPC. Then it is telling, once you will assign that CIDR block, then you have a choice to select the IP address range, because this IP range you have defined. Now all the instances which will be launched with this IP range will be of your Flash only, because you have defined the IP range of CIDR block. Second is creation of subnets. So inside the VPC, we also create. We have to divide this VPC into a smaller, like smaller parts, and each part is known as subnets. So you can create, like different subnets inside VPC. So that is your choice. Now inside that, configuration of route table and networking gateways. There are other components like route tables are there, networking gateways are there, which you only define. So inside your VPC, you are defining everything from your end. So you are having control over all the virtual network resources. Okay, so to create this, VPC, we need multiple network resources also. So since you are creating those resources, you are doing the configuration of the resources. So everything is under your control that they want to do. Now enable you to customize the network configuration for your VPC definitely. So currently you are not using a default VPC. That means you are creating your own VPC in a customized way based on your requirement. Based on requirement, you are creating a CIDR block. You are defining the subnets. You are creating the network gateways, route tables, etc., etc. Enables you to use multiple layers of security. And with the help of VPC, you can use multiple layers of security. Once you will go to VPC security section, I'm going to tell you what are the different, form of different different security components are there, which you can use to make your VPC secure. Now, let me asking what difference between VPC and VPN. Okay, so VPC is a virtual, like VPN is a virtual private network, Nathan. VPC is a virtual private, like a virtual private cloud. So this you are defining on the AWS platform, and VPN is a secure tunnel connection. If suppose you are, we are running an application. Okay, suppose we are running an application on a hybrid model. Suppose I'm using a VPC. I'm using a VPC at the Amazon level, and then I have some on-premises servers on my on my data center, my own data center, and we are creating a hybrid solution. Now, what suppose at my on-premises what do you say on my on-premises data center, I'm running my web servers. At VPC, I'm running my database server. Now, how I'm going to securely connect that? I can do the connection. I can connect my VPC to my on-premises using the VPN connection. That is a virtual private network. One secure tunnel will be created as a VPN connection, and VPC is a place where you are defining the resources, where your application, where your database application, where your database server is hosted on my AWS. That's the difference between them. Inside the VPC, you define the resources, you create the infra using the VPC. But inside the VPN is a secure way to connect your hybrid model. Okay. Now you got it? Nathan, is it clear? Ignito is a thing. Ignito is a user access. It controls the user access. Here we are talking about the hybrid model that we are connecting to the VPN connection, which is a secure connection, VPN connection. Like for example, you guys would have played this Counter Strike game, okay, multiple times on a single, you would have created one connection. On that only you would have connected. So that was a secure connection, VPN connection. On multiple people are connecting, and you are playing a game. That's the example of VPN connection. Gajana. maybe in your college days you would have played this Counter-Strike in your labs. So we used to create one, connection, okay, and on that we used to we all will join and we are going to play the game. That is the example. VPN will come, okay. How to use VPN? AWS VPN is a topic, but Nathan has asked that question. That's why I've given him the example and the explanation how VPC is different from VPN. Both are different things. Okay. Okay. Now you understand what is VPC. It is a logical isolated area, which is where you can define your own network. Inside that you can launch your AWS resources, and here you will have maximum control on VPC, and it is a customized network, and it also provides you multiple layers of security. Okay, now what are VPC and subnets? Let's check out. So VPC was a logical isolated from other VPC. So one VPC, suppose you have created two VPCs inside a single region, those VPCs will be isolated from each other. Okay, dedicated to your AWS account. A VPC is dedicated to your AWS account, and VPC is a regional service. It belongs to a single region. Suppose, for example, I have created one VPC inside the Mumbai region, and suppose if I will change the region to North California, I won't be able to see the same VPC. That's why it is a regional service, guys. Okay, you understood now what is regional service. So, and now what are the subnets? So these subnets are the, we used to divide the whole VPC inside different subnets. So let me take a look at this diagram. Inside the AWS cloud, we are into suppose we are in Mumbai region. In Mumbai region, I created one VPC. And inside the VPC, I have divided the whole VPC into a smaller subnets, into a smaller network part. So look at this. I created two subnets, and subnets are classified as public and private subnet. So you create public subnets and private subnets. So range of IP addresses that divides a VPC. So for example, if suppose this was the range of my IP address, let me tell you just a minute. Let's take this as 28. And if I divide here, make it as 28, it will come as 4 bits, and 2 to the 4 is 16. Suppose this was the CIDR block of your VPC. This was your VPC CIDR block, guys. Okay, now suppose I have to create two subnets. Then what I will do, I will divide this IP range into a smaller part, into two parts. Suppose I am creating a two subnet. Then what will be here? Okay, each subnet will have your, each subnet will have a divided part of the CIDR block. So, for example, suppose subnet 1 is going to have your, 8 IPs. I'm going to assign 8 IPs to subnet 1, and for subnet 2, I'm going to assign the 8 IPs. So what I'm doing here, I'm just dividing this whole network. The whole network got divided into a smaller network. That smaller network is known as subnets. And inside these subnets, we are going to launch your servers, the web server, application server, or database server. You got it? What is subnet? You are dividing your VPC into a small, into your, different and small range of IPs, and those range of IPs are known as subnets. So this whole CIDR block of VPC is divided into a smaller part, and each part is known as a single subnet. So let's suppose, what will be the CIDR block of this? Let's calculate this, okay? So suppose if I am assigning 8 IPs here for this, so the CIDR block will come like 10.0.0.0. I think it will be divided by 30. 30. So we will get here 32 minus 29. Yeah. So this will be a CIDR block of the first subnet. So 32 minus 29 will come as 3 bits, which means 8 IPs. 2 to the power 3. That means 8 IPs. So now what is the IP range of a subnet? It will start from 10.0.0.0 to 10.0.0.7. That will be the IP range of subnet 1. Okay, that will be the IP range of subnet 1, which means in subnet we can launch 8 instances. Yes, we can launch 8 instances in each subnet. Okay, so now you got it. The subnet 1, the same way. So now what will be the IP range here? The IP range will start from 10.0.0.0 to 10.0.0.7. This is the IP range of subnet 1. Now in the same way, you will also get you have also divided and given the equal number of IPs to subnet 2. So now at subnet 2, the IP will be start like 10.0.0.8 to your 10.0.0.0 and it will come as I think 8, 9, 10, 11, 12, 13, 14, 15. This will be your 0 to 15 means 16. Starting from 0, adding to 15 means total 16 number of IPs. And since we have divided into 8 bits, so this will be the IP range. The IP range of subnet 1 will be this, and the IP range of subnet 2 will be this one. That's how you create the subnet. Now suppose inside the subnet 1, when you're launching any instances, the instance will have this IP range. The IPs will be associated between this range. And suppose if you're launching any instance inside subnet 2, then the IP will be associated between this range. Suppose you are launching any instance in subnet 2, then IP will be like 10.0.0.30 because you are launched inside the subnet 2. Okay, now you got it. What is subnet and how to divide? We are dividing a VPC. VPC is a bigger CIDR block. You can understand VPC is a bigger CIDR block. Inside that I have created two subnets, and those subnets are having a smaller CIDR block. So ultimately both subnets are the subsets. Subnets are the subset of your VPC. Like we have, we do this. What do you say? Like we do this Venn diagram. We have the subset. Subset is a part of a bigger area. So VPC. So these subnets are the subset of your CIDR block. What is the network mask of subnet 2? It will be the same only. The network mask of subnet 2 will be this also. It will be the same. It will be 10.0.0.8 because first it is going to take the starting IP divide by 29. Because when we are using the same submasking only, then too we are getting the range of IPs. We have to equally divide the IP. That's why we are going to use divide by 29. That is a submasking. Money inside subnet only, you are going to create the money. Subnet is used to make all the resources isolated to each other. So suppose like if you will see the diagram, this subnet 1, this subnet belongs to availability zone 1. The subnet 2 belongs to availability zone 2. A single subnet belongs to a particular availability zone. You can have multiple subnets inside a availability zone also. So to isolate your resources inside your inside your VPC, it is done with the help of subnet. So suppose you want to create database server and web server. I'll give you an example. So as I told you, these subnets are classified as public and private. So inside the public subnet, you can create a web server. Inside the private subnet, you can create a database server. Now both are isolated to each other because both are the part of different CIDR block inside a VPC. To isolate your resources, we use subnets. Okay, you got it now, Mani? How many IPs are given to subnet 1 and rest are? Yes, Philape. First, I think we have given to first 8 IPs we have given to subnet 1 and the last 8 IP we have given to subnet 2. Now you got to get the subnets. Subnets are the subsets of your VPCs, and the subnets are classified as public subnet and private subnet, and the subnet belongs to a single availability zone. Suppose if you are creating multiple subnets in your VPC, a single availability zone can have multiple subnets also. But generally, if suppose there are you're creating your infra inside Mumbai region, and Mumbai region is having three availability zones, and you only want to create three subnets, you can create either in a single region or you can create under a different availability, not a region. Either you can create all those subnets inside a single availability zone or in multiple availability zone. Why we go multiple availability zone? To make our solution highly available. I've told you about one high availability of your application. With the help of subnets and all, we are creating subnets in different availability zone. That means we are making a solution highly available. Because suppose if there is a web server inside your availability zone 1, and you have a database server which is inside your availability zone 2. If something goes wrong to availability zone 1, then only your web server will be impacted. Your database server will be still up and running. Okay. Yes, it is a child of VPC. Yes, man. It is a subset or a child of VPC. Now, I think Nitin, you were asking me the difference between CIDR and subnet, and now I think it is clear to you. Okay, CIDR we use for both. Listen, VPC and subnet. Just we are dividing the VPC network into a smaller component, and these components are known as subnets, and they are also having a CIDR block. Somebody is asking, sir, we with these subnets can communicate if we assign it to. Yes, that will come. They have a component for communication. We have another component. Don't worry, Ravi. I'll tell you how you communicate between these things also. Okay. Okay. Yeah. Okay. Now you're telling. Okay, Nathan. Look at this, Nathan. So the first IP range was this one. For subnet 1, Nathan, this was the IP range 0 to 7. Now definitely for subnet 2, I'm going to start with 8th IP. Correct? So now from 8th IP, this will be your first IP that you are defining here. I'm dividing by 29. If I'm dividing by 29, I'm getting total of how many IPs? 8 IPs. So starting from 8, 9, 10, 11, 12, 13, 14, 15. It will end to 15. It's a simple mathematics. So this will be your first IP address. First IP will start from 10.0.0.8. It will go to this range, dot 15. Is it clear now? Yeah. Yeah. Yes. You can create n number of subnets, Kishan. You can create n number of subnets. For a single region, you can create maximum up to 200 subnets. Okay, you can create. So it depends on your architecture. There are multiple, depends on your business case, how many subnets your clients want you to create. Maybe there are, few architecture I've seen where they use only 2 subnets. I've seen few architecture where they use up to 8 subnets. It depends on your application. It depends on your application itself. Okay, how the application is designed, how your client want you to create the infra. Okay, so now you understood what is subnets. Now let's move to other components, guys. Okay, let's go ahead. Yeah. Now the IP addressing, this thing I've already explained you. When you create a VPC, you assign it to a IPv4 CIDR block. So IPv4 CIDR block is this kind of a thing. I've already explained you through through this notepad. You cannot change you cannot change the address range of when you create VPC. So you have to make sure whenever you are creating a VPC, guys. Okay, whenever you are creating a VPC, that time you have to assign a one CIDR block. So once the VPC is created, then you cannot modify the CIDR block range. So you have to first calculate everything, then you should assign a CIDR block range to VPC, because that you cannot modify later. Okay. The largest VPC block size is divided by 16. Actually, it is not true. Okay. Largest will be divided by 0. This is a subnet masking. We all know, using this subnet masking only, we are making how large will be the VPC. So for example, this particular VPC was having divided by 24. That is, it can only have 16 IPs. If suppose I am reducing the value of this network masking, like making it as 16, then definitely 16 means divided by 16 means it will be having large CIDR block which contains 65,536 IPs. So with the help of this network masking, you make with the with this network mask, you can define a large and a small VPC. So it is telling divided by 16 is the largest. No, divided by 0 is the largest VPC, and it's telling divided by 22 is the smallest VPC. No, if you are dividing something by 32, that can be a smallest, because it is only having a single IP range. Okay. Now IPv6 also support, apart from IPv4, VPC also support the IPv6 IPs. CIDR blocks of subnets cannot overlap. So CIDR block of subnet cannot overlap. This means here I have created 2 VPCs. Sorry, 2 subnets inside a VPC. So the range of both subnets should not be same. If the range is same, then when you are creating the subnets with the same IP range, it is going to give you the error. For example, if suppose I am giving the same value for subnet 2 also. If suppose I am giving a same value for subnet 2, like suppose subnet 2 is also having the same IP, if I am defining like that, like 0 and 7. Make it at 0. So this means first I will create one subnet 1 with this IP range. Now second, when I'm defining the CIDR block for subnet 2, I am defining the same way, the same value, exactly subnet 2. Then it means it is like you are overlapping the IP range. Then it will give you automatically the console will give you error because already this IP range has been associated to another subnet. Please choose another IP range. That's why the subnet IP range, the subnet CIDR block should be unique. It should not be overlapping. Overlapping means when you're using the same range with two subnets, you won't be able to create the subnet because it is going to give you an error. Error will be displayed on your console. I will once we will do the lab, then I will show you. You will get the error. That's why you have to define a unique IP range, guys. Let me just correct this. Okay, let me just correct this again so that it will be unique. Okay. So this was the meaning of that last statement. CIDR blocks of subnets cannot overlap. Okay. Now let me take few more questions. When we have set power for also there are two networks for the AWS infra. Two networks of AWS infra. Srikanth, two networks means the VPC is a network. Inside that you can define n number of subnets as per your business case. Now Sudha is telling no, it doesn't mean we cannot take 29. It will be taking 29 only. But this is the IP range. It should not have the same IP. Subnet 2 should not have the same IP range, Smita. Okay. One more question is there. Let me take. Can we create a password for these IPs inside VPC? Can we create? Why you have to create the password for the IPs? You have to create a password for your machine. These IPs will be associated to your machine money. Ultimately, you are going to access your machine through the public and private keys. Okay, so once you will have those keys, then only you can access the machine which is having this particular IP address. Okay. I think I've answered all the queries. So Ashmita, money, is it clear? Okay, so now this part is done. Okay, IP addressing. Let's move to another slide. Now there is some concept of reserved IP addresses. Now what happens, guys? There are 5 IPs are there which are reserved by Amazon in each subnet. Okay, that's why we don't create so many, low subnets like divide by 28. We create something subnet like divide by 16 or divide by 20 or 22. So we will get a large IP range pool. Okay. So here, why? Because 5 IPs will be taken by AWS for the internal communication. So for example, a VPC with an IPv6 CIDR block of this divide by 16. So now how many total IPs will be there? 32 minus 16, that is 2 to the power 16, and will come around 65,536 will be the total IP address. Now suppose they are making 4 subnets here. This was the CIDR block of subnet of VPC. Now they have created 4 subnets, and each subnet they are associating 256 IPs because now the masking they are using 24. Now 24 is the masking. That means each subnet will have 32 minus 24, that is 2 to the power 8, 256 IPs. As I have told you, Amazon is going to reserve 5 IPs of each subnet. So it is telling 251 IPs in each subnet will be associated. Like whenever you are going to launch any machine, it is going to take from only 251 IPs because 5 IPs will be reserved. Now what are those 5 IPs which will be reserved? Now if you will see, these are all identical, like these are all unique subnets. How? Look at this. 10.0.0.1. Since it is divided by 16, first 2 bit will be fixed. Other 2 bit will be modified. So look at this. First subnet is 10.0.0.0 divided by 24. Second subnet is 10.0.2. The fourth subnet is 10.0.1. The third subnet is 10.0.3. So this is a unique IP range. Look at it. Nothing is overlapping. This thing is clear. Now how what all those 5 IPs Amazon is going to reserve? The first 4 IP and the last IP address. Suppose let's take an example of the subnet 1. So inside the subnet 1, IP range is starting from 10.0.0.0. This will be a starting IP. Like here what I have told you in subnet 1, what was the starting IP? .0. That's why we have created a submask of 10.0.0.0.0 divided by 29. Inside the subnet 2, what was the starting IP? 8. That's why It started from this IP range 10.0.0.8 divided by 29, which is a submasking. So same way, let's continue at the subnet one. So the first four IP will be 0, 1, 2, 3. That will be reserved, and the last one. So the first will be reserved for network address, their internal network address, and dot one for internal communication, dot two for DNS resolution, dot three for some for feature use. Suppose if there is any internal network component failure happening inside the VPC at Amazon level, then they can use this. And finally, 10.0.255, which is the last IP of the subnet one. That is for network broadcasting address. So these are the 5 IPs which are reserved by Amazon guys for different purposes. So if you are creating, suppose you are creating like 4 subnets of 16 IPs each, then you will find that only 11 IPs you can assign to your machine size. 5 will be reserved. So you can only create 11 machines inside a single subnet, which is having 16 IP range, because 5 IPs, the first 4 and the last one will be automatically reserved with Amazon for these purposes, guys, for the different internal purposes. Okay. How we can decide that 2 digits are not changeable? By masking. I've told you the concept of masking. When you're masking here, Ashmita, when you're masking divided by 16, that automatically I've told you, it is going to go from right to left. So when you are masking by 16, one IP v4 address is having 32 bits and each octet is having 8 bits. So 16 means you are fixing 2 octets. You are fixing 16 bits of your 32-bit IP system. So when you go from right to left, the first and second will be fixed. Now all those modification will be done on the last 2 bits. That's how you fix using the network fix. Okay. Okay, now you understood the reserved IPs. The 5 IPs will be reserved in each subnet, and that is for internal communication. So in this example, each subnet is having 256 IP range, but why you are seeing here 251? Because the 5 IPs of each subnet is reserved, and it is reserved for the internal communication. The first 4 IP, suppose the first 4 IP and the last IP will be reserved of each subnet. So suppose let's take an example of the subnet 2. If suppose it 10.0.2.0, then 10.0.2.0, 2.1, 2.2 and 2.3. The first 4 IP will be reserved, and 2.255, the last IP will be reserved. So you can create up to only 255, 251. You can assign 251 IPs only inside this subnet, because 5 IPs are reserved in each subnet. Okay, now you got the concept. Because once you will create the subnet also, then also I will show you that we have created the subnet with this IP range, but you can see 5 IPs are subtracted from your IP range automatically, because those are used by Amazon only. Okay. Now let's take a difference between what is public IP address and your private IP address. So there is one public IP address is there, which you assign manually through an elastic IP. So these public IP addresses are used for communication over the web. So suppose whenever suppose you are trying to access any website like www.google.com, at the back end of that website, some public IP address would be associated, guys, which is hitting that server. The server is having that IP address attached to, which is the address of the server, and on that server your application is hosted. So ultimately you are mapping your host name to that particular IP address of your machine, where your all query will be sent to that particular machine where your application is hosted. So that is your public IP address, which is manually assigned through a elastic IP address, automatically assigned through the auto assign IP address setting at the subnet level. So there are 2 ways you can assign your public IP address. Okay, so public IP addresses are dynamic in nature. First I'll tell you the difference. They are dynamic in nature because suppose if I'm launching any instance and I'm getting some IP address, public IP address, if I'm restarting that machine again, if I'm stopping and starting the machine again, now what is going to happen is going to change the public IP address. Okay, that's why we also use elastic IP address, which are static in nature. So elastic IP addresses are static in nature. So you have to first request the IP address from AWS, then they will give you an elastic IP address, and once you will attach that IP address to any machine, then whether you restart your machine, whether you reboot your machine, nothing is going to happen. the IP address will be same. It will be static. That's the main difference between public IP and elastic IP address. Now it told you that how you can assign the public IP addresses. You can assign in two ways. Either first of all, if you will request the elastic IP address, then your machine will get one, like address which will be static in nature, and that address you can attach to a machine as an elastic IP address. Okay. And otherwise, when you are configuring, configuring your machine on this page, for example, let me show you. When you are configuring your machine on this page, so based on your subnet setting, so look at this. Here it is telling auto assign IP public IP enable. So automatically it's going to assign public IP to this machine. It is going to be done automatically. So that's why it is telling this public IP assigning in two ways, either using the elastic IP address. So once you request the elastic IP, then that elastic IP you are going to attach to your machine. So your machine automatically get one public IP address. Secondly, using the subnet setting. So at the subnet level here, it is telling you subnet setting enable. That means automatically one IP will be assigned, public IP will be assigned to your machine when this instance will be launched. Okay. And now what was the difference between public and elastic IP? Public IPs are dynamic, I told you. Whenever you are assigning the IPs to the subnet level setting automatically, then when you're restarting the machine, those IP addresses will be modified. It will be changed. So to come over this challenging thing, okay, we use elastic IP addresses where we buy the IP addresses from Amazon. So each region, we can have maximum up to 5 elastic IPs we can request. Once you get the IP, you can attach it to the machine. So you have to pay some amount for each elastic IP using like per hour wages are there, very low are there, but you have to pay. Elastic IPs are chargeable. So you have to request elastic IPs. You will get the elastic IP in your AWS account, and per region, maximum 5 IP address you can get, and you can attach to your different machines. And once you restart those machines, this IP address won't be changed because these are static in nature. Now let's check out elastic IP. It is associated with AWS account. Definitely, it will be associated with your AWS account because you are requesting that. Can be allocated and removed anytime. Now suppose you have requested one elastic IP. You have attached to instance number 1. Now suppose you have to terminate the instance number 1 and you have to launch the instance number 2. So you can also remap that elastic IP. How to remap means, first of all, that elastic IP was mapped to instance 1. So you can, before terminating the instance, you can detach the elastic IP, and once you will create the instance 2, then you can attach that elastic IP. That's why it is reusable, remap. Additional cost is there, definitely. For using these static IPs, we have to pay some amount. The main difference between normal IP, public IP, and the elastic IPs, public IPs are dynamic. They will be changed when you will restart your machine. Elastic IPs are static. The IPs won't be changed when you will restart your machine. Okay, that is a difference. And elastic IP you have to pay. Public IPs are free. Now I was telling you, static means it won't be something which is static, which won't be changed. Dynamic means which can be changed. That is the meaning of static. That is the meaning of dynamic, which can be modified. Static means which won't be changed. The form. Suppose I am this is a you see website money, once you open Amazon.com, then there is one Amazon written on the top. That is a static content. That won't be changed. But down you will see some slides are there, some some data is there which is getting manipulated. Suppose you are searching in the search bar, then you're getting some dynamic data that is changing with each request. But that Amazon logo is static. So it is static, it won't change. Dynamic means it will change. Okay. So is there any problem if a public IP is changed? Yes, it will be a problem if public IP is changed. Suppose you have mapped you have mapped your domain name with one IP name. That was the IP name of your machine. Now once you will restart that particular machine, then what will happen? The public IP address of that machine will be changed. That will be changed. Now how the DNS will come to know that the IP address has been changed? Because the older IP address is attached to your machine. So then your application will get a response application not found. Because now the machine on which the application is hosted, the IP address has been changed. That's why we go for elastic IP addresses. Okay, now somebody asks me, Elastic and private IP are same. No, Elastic and private IPs are not same. Private IP are used for internal communication, guys. Elastic IPs are for the public communication. What is the internal communication? Suppose you are creating a VPC. Inside the VPC, you are creating multiple components. So for internal communication of those networking components, we use private private IPs. And for all the public communication, we use the public IP. Each and every, like each and every machine will have minimum of one public and one private IP. Private IP is used for internal communication. Public IP, as the name says, it is for the public communication. So all your public server, like suppose if today I'm going to search something on google.com. Then once I will search on google.com, then google.com, DNS name will be attached to some public IP. Okay, then the request will move to that server, which is hosted, which is attached with that to a public IP, and then I will get the response. So it is for public communication. Okay, guys. Okay, I think I've answered everything. Nothing is left. Okay, so I think now you got the difference between the public IP and the elastic IP. So one more thing, I will tell you. Okay, many people don't know what is the difference between reboot and restart. So suppose if you are rebooting any server, that means all your current operations won't stop. If suppose you are rebooting your machine, guys, then what it is going to, it is going to your refresh your computer. We refresh your computer so that maybe suppose why we reboot the machine, we are getting a bit latency. We are doing some job, our computer is not responding up to the mark. It is becoming a bit slow. So we go for reboot. Once you reboot, it is not going to stop all your going processes, all your computer processes is not going to stop. It is going to just refresh it. So when you are rebooting your server, that time this public IP won't be changed. It will be only changed when you are restarting. Now when you are restarting something, that means it is going to stop everything and it is going to restart your operating system. That is the difference between reboot and restart. So when you are rebooting your machine, that time your public IP floor address won't be changed, only at the time of restart. Rebooting means just refreshing your computer. Restart means you are closing down all the operations and you are restarting your operating system. That means all your processes will be terminated, and once you will restart, you won't be seeing any saved option. For example, you can do it in your machine also. Just open or like open different tabs on your browser and just reboot your machine. Once you will reboot your machine, then once you will log in back to your machine, you will see the same for Google pages and other processes running. When you are restarting the machine and once you log in after the restart, then you will see nothing has been saved. Okay, you have to open all the Google, like all these pages again. That's an example of restart. Okay, now you got it. Reboot, and what is reboot? What is restart? When you're rebooting anything, when you're rebooting your EC2 machine, that time public IP address would change. Only at the time of restart is going to change. Okay, so we are going to end the session till here. I hope I'm doing very slowly the session. I hope you are understanding all these concepts pretty much well. These are the building blocks, right? That's why. Let me just give you the feedback form and just provide the feedback. If you have any other further question, you can ask me. Okay, anything? I have noted down your two queries. I'm going to answer you tomorrow because those are all actually network these network deep network concepts are there. So I have to look because I'm not a network engineer. That's why there are few things which are also out of scope. But I'll tell you the answer tomorrow. Okay, so I'm just putting you this form. Okay, please use it for the feedback. Okay, we'll wait for a minute. Anything else is there? If anything else is there, I'm going to ask. You can ask me any other question. Book for AWS for Solution Architect, author name. No book, Amina. Amina, no book. Documentation will be there. First, whatever I'm telling you, you understand that in the class, and then everything will be on AWS documentation. If you want to learn anything or for any service, go for documentation. There is no book and all stuff is there. Documentation is the Wikipedia. From there you can learn anything on AWS for AWS platform. Okay, guys, I think nothing is there now. I hope you guys are giving the feedback too. So let's close the session today, and we're going to meet tomorrow. Thank you so much for joining the session, and I see you tomorrow. And we're going to do that lab tomorrow, okay? Because still some problem is there. I have to talk to them to resolve this issue. Okay. Okay, guys. See you tomorrow. Thank you so much. Have a good night. Bye bye.